Hi and a very good day everyone. We are students of LO1 BO1 from Electronic Device and Circuit subject here to present on the power amplifier. We are consists of 4 in this group and I am Puvindraj K. Sivasubramaniam.
I am Muhammad Tami Akmal bin Yaakob.
And I am Nur Farah Edimidino Azman.
And I am Fatima Nashha binti Bahunidin.
For the content part, we have touched on several parts, which is the introduction, characteristic, application of class A, class B, class AB, class C, simulation and the calculation. For the first part, let's see on the class A. Class A amplifier is a very high gain amplifier with high linearity. The conduction angle is 360 degrees. What is meant by conduction angle? It means the amplifier device remain active for the entire time and use complete input signal. Let us refer to the circuit given. From the circuit, we can see that there is only one active element, which is the transistor, and the bias of the transistor remain on for all the time. Next, the advantage of class A amplifier is ideally there will be no distortion occur, but the disadvantage is the efficiency is low. For the class A efficiency, for the maximum part, it can go up to 25% theoretically, and for practically it can go up to 15%. Usually it is used as pre-amplifier and low audio amplifier as found in radio. The amplifier is biased at the midpoint and the Q point will be located at the center of the load line, which is shown in the figure below. For the next part, class A amplifier, the characteristic is it is biased at the midpoint, the Q point located at the middle of the load line. For the efficiency, the conduction angle is 360 degrees and the amplifier's efficiency is between 15% to 25%. For the distortion level, the output signal is undistorted. Moving on to the next, the simulation part of the class A amplifier circuit. Actually, this is the circuit. We have insert one oscilloscope to identify the wave. For the results of class A amplifier, we obtain two waves. The red color wave is known as input and the blue one is known as output. From this, we can see that there is no difference between the both input and output wave. So the conduction angle is 360 degrees and it is actually a full wave, as we can see from the result, with a positive and negative signal. So from this result, we can prove that class A amplifier, okay, there will be no distortion occur. The advantages of the class A amplifier. It is produce undistorted output signal and high frequency feedback loop stability. For the disadvantage, it is low efficiency and there will be a high power loss. For the application, it is the class A amplifier. It is used in the pre-amplifier, low power audio amplifier and instrument amplifier.
Okay, for class B, if the collector current flow only during the positive half cycle of the input signal is called as class B. In class B, power amplifier operation, the transistor is so adjusted that zero signal collector current is zero. During the positive half cycle, from the figure, we can show that the input circuit is forward biased and hence the collector current flow. But when during the negative half cycle, the input circuit is reverse bias and they have no collector current flow. Okay, next. The figure shows the operation of class B operation amplifier in terms of AC load line, and it also shows that the Q point is on the cut-off line, which is located at collector cut-off voltage. This results in distortion of signal since only half of the signal is amplified at the output. The efficiency is theoretically 78%, but practically 50%. Okay, next. Since class B only produces half cycle of the signal at the output, so we can obtain full wave by using push-pull amplifier. In this push-pull amplifier, it uses two transistors, which is NPN and PNP. NPN will produce positive half cycle of the signal, but PNP will produce negative half cycle of the signal. Okay, next. The transistors are biased at cutoff. The input signal must overcome VBE of the transistor, which is about 0.7 volt before the transistors are on. This produces a distortion in the output signal, known as crossover distortion. It means that they have no current flow when VBE didn't reach 0.7 volt. Okay, next. In class B, the characteristic is bias at cutoff. The Q point is located at the cutoff point of the characteristic curve. The efficiency, the current will be flow when the transistor is only 180 degree. This improves the efficiency of the amplifier to 50% to 75%. In class B, the distortion level have high distortion. Okay, next. Okay, this is simulation of class B circuit. In this class B circuit, you have one transistor and one power supply with 18 volt. Okay, the result show the blue one is the input and the red one is the output. It shows that the output will only produce half cycle of the signal in class B. Okay, next. Okay, this is a class B push-pull circuit. In this class B push-pull circuit, as been taught earlier, it uses two transistors, which is NPN and PNP. Q1 is NPN, Q2 is PNP. It also uses two power supply, which is VCC 18 volt and VEE at negative 18 volt. How this circuit works? It works by the input signal is having positive cycle. So positive cycle will appear at the base of both transistors. But during positive cycle, only NPN will turn on. It because positive value at the base will be higher than emitter. We know that only 0.7 volt between base and emitter. This is why only NPN is turned on. Then the output will produce from the load of R3 will getting signal from positive VCC. Basically, the transistor will bias and power supply will push current to produce the output. But when positive cycle of the signal, Q2 will be off. It means that it's an open circuit. But during the negative cycle of the signal, Q2 will be off. Q1 is off because it has negative value at the base at Q1. But Q2 is on because Q2 base is less value than emitter. That is why emitter is connected to the ground. That ground only have 0 volt. That is why it have less value. So it's a pulling current from the load is from negative 18 VEE to produce the output. That is why it called push-pull amplifier. Next. From the result, we can see that it's improved from the signal from class B. And the class B only have half cycle of the signal, right? So in class B push-pull, it have positive and negative cycle of the signal. But it have crossover distortion, if you notice that, from positive and negative, right? Because, why? Because it have two transistors. Because in push-pull circuit, it use two transistors. And when this crossover distortion, the two transistor is off. Because it doing a changing between on and off. And it also because no 0.7 volt at VBE. Okay, next. There is have advantage and disadvantage in class B. The advantage is high efficiency when compared to the class A configuration. Second, push-pull mechanism avoid even harmonics. The disadvantage is the crossover distortion as been taught earlier because current does not flow until VBE reach 0.7 cause high distortion. There has three examples of application which is audio power amplifier, PA system, and DC servo motor amplifier. Okay, next I will pass to Ami.
Alright. For class AB amplifier. Class B amplifier is basically an improvement of Class B amplifier to overcome the effect of crossover distortion. To reduce the crossover distortion, we will place two diodes at the base of each transistor and it will become a Class B amplifier. The conduction angle is greater than 180 degree but much smaller than 360 degree. Next. This figure shows that the Class AB amplifier circuit, the example of the circuit, and the position of the Q point. I will explain the position of the Q point in the next slide. Next. Okay, there are 4 points for the Class AB amplifier, which is the first one is characteristic. Basically, Class AB is biased between Class A and Class B. This can show that we shown at the Q point, which is Q point is between cutoff and the middle of the load line. When the cutoff is basically the Class B, while the middle of the load line is basically the Class A. So the Q point is for Class AB amplifier is between both of the Class A and Class B. For the efficiency, the current flow in the output more than 180 degrees of the input signal, but less than 360 degrees of the input signal. So the efficiency for the amplifier is 38% to 50%. The distortion is level is higher distortion than Class A, but lower than Class B. So you can see that at the this simulation circuit, this is basically an example of Class AB amplifier multi-sim circuits. For this circuit, I take the previous Class B push-pull circuit and add 2 diodes. Okay. The reason why we put the 2 diodes is because silicon diodes provides a constant voltage drop of 1.4 volt between the 2 bases biasing them above the cutoff. This will cause the transistor will always active during the biasing. I will explain the detail on the output result. Next. Okay, as you can see at the left, which is the Class B output result, we know that Class B output result have a small distortion which is called crossover distortion. This is because of the 2 transistor operate, which is when the positive transistor operate, the negative transistor will be off. So to overcome this type of distortion, by adding the 2 diodes, silicon diodes, which have the 0.7 voltage drop, it can active both of the transistor at the same time during the biasing. So as we can see at the Class AB output result, there by adding the 2 diodes, the distortion have been overcome or been reduced. So this is the proof that The two by adding the two diodes can overcome the crossover distortion. Next. Okay. Every class of amplifier have their own advantage, disadvantage, and application. For class A, B amplifier, the advantage I have been explained earlier, which is it can overcome or reduce the distortion that caused by distortion, which is the crossover distortion by the class B. The disadvantage for the class A B amplifier is it has less efficient than class B amplifier. So the application of class A B amplifier in our daily life is mainly used in high quality audio power amplifier because AB amplifier produce high quality output as they have low crossover distortion and have a high linearity similar to the class A. Okay, that's all from me.
Okay, for the Class C amplifier, Class C amplifier is tuned amplifier which works in two different operating modes. Firstly, it's tuned, and the second mode is untuned. Alright, during the untuned mode, the tuner section is omitted from the amplifier configuration. When the circuit is exposed to a tuned load, the circuit clamps the output bias level with the average output voltage equal to the supply voltage. The tune operation is called as clamper. During this operation, the signal gets its proper shape and the center frequency becomes less distorted. Next. Alright, Class C power amplifier is a type of amplifier where the active element, such as transistor, conduct for less than 1/2 cycle of the input signal. Less than 1/2 cycle means the conduction angle is less than 180 degree and its typical value is 80 degree to 120 degree. The reduced conduction angle improves the efficiency to a great extent but causes a lot of distortion. Theoretical maximum efficiency of a Class C amplifier is around 90%. Due to the huge amounts of distortion, the Class C configuration are not used in audio application. Next. Okay, this is the example of the Class C amplifier circuit and also the Q point. Class C amplifier are commonly used in high frequency sine wave oscillator and certain type of radio frequency amplifier only because of its heavy audio distortion, where the pulse of current produced at the amplifier's output can be converted to complete sine wave of a particular frequency by the use of LC resonance circuit in its collector circuit. Next. Alright, for the characteristic of the Class C, it's its bias beyond cut-off point. For the efficiency, the transistor conduct for less than 180 degree of the input signal. Thus, the efficiency is between 70% to 100%. It is very high distortion level of the Class C amplifier. Alright, for the Q point is located below the cutoff point. In this slide, you can see the conduction angle of the Class C is between 100 degree to 150 degree. Next. Alright, this is the example of the simulation Class C amplifier circuit. As you can see in the slide, we put two oscilloscopes to get the result of the circuit. First, we put oscilloscope on the input and also the other one on the output. Next. So this is the result that we produce from the simulation. You can see from the left is it Class C input result, and from the right is it Class C output result. We can see there's a very high distortion on the output result. Is it because because in class C amplifier, VB is set to a point where the transistor will be at below cutoff mode, and the DC operating mode is below the cutoff point. Less than half of the AC input signal will be amplified and present at the output terminal. Very high distortion occurs when the transistor is at cutoff mode during negative cycle of the input signal. So this is why we get a very high distortion on the output result. Next. Alright, for the advantage of the class C amplifier, it is very efficient theoretically 100% and excellent in RF application. Alright, for the disadvantage is its lowest linearity and produce output with severe distortion, and also its reduced dynamic range. Alright, for the application that use class C amplifier is its tuned RF power amplifier and FM transmitter, booster amplifier, and also RF oscillator. That's all from me.
Okay, thank you. Move to the next part for our task is the calculation for this circuit. Okay, we have been given the circuit at the left and provide with a value which is the RB, RC, VCC, and beta. Okay, we will find the characteristic of this circuit, and first characteristic is the DC analysis. By applying the DC analysis, we can obtain three value which is IBQ, ICQ, and VCEQ. Okay, for IBQ, by using the formula VCC minus VBE over RE, by inserting the value that have been given, we will obtain the value of IBQ, which is 3.6 milliampere. And for the ICQ, we need to obtain value from IB and will be time with the beta value, and we obtain that ICQ is equal to 0.944 ampere. And the last is the VCEQ value by using VCC minus VC and derive the VC to ICRC. Okay, by inserting the value that's given, we obtain the value for VCEQ is 9.17 volt. By having these three of calculation and the value result, we can sketch the DC load line and can identify the class for this circuit by referring to the DC load line. Okay, I will pass this to Puvin.
Moving on to the next. To find out the DC load line, first, assume VCE saturation is equivalent to 0 volt. For the IC saturation is equivalent to VCC divided by RC. Substitute the values and we will obtain 0.6 ampere. For the next one, IC cutoff. Assume it is 0 ampere and VCE cutoff is equivalent to VCC, which is 18 volt. Okay, I stated in the lab sheet. So to plot the DC load line, identify the VCE cutoff and also IC saturation. Usually, when we want to plot the DC load line, the IC saturation will be, the IC will be in milliampere. So 0.6 ampere convert into milliampere will be 600 milliampere. So the Q point will be 9.17 voltage and 294.4 milliampere. This is the DC load line. Next,
okay, for the power output, we can find the power output of the circuit by using the formula 0.5 times by ICQ and also VCEQ. So we substitute the value the value that we get from the calculation before. So we substitute and get the power, the output power equal to 1.3 volt. All right, for the power consideration, we using the formula VCC times by ICC. So equal to 2 ICQ times by VCEQ. So we substitute the formula with the value that we get. So we can get the power consideration equal to 5.4 watt. And also we can get the efficiency using the formula power output of a power consideration times by 100%. So we substitute the value and we get the efficiency equal to 24.07%. So we can assume that is it class A, and so the example of application that use class A is such as pre-amplifier. Okay, next I will pass to Adli.
So for the question, we can conclude that we could identify the difference between the class in terms of application, characteristic, efficiency in class A, AB, B, and C. We also can see the difference between result when we analyze the circuit by simulating or by performing calculation. We also can see the difference in the location of Q point in the DC load line because each class has its own Q point due to the different characteristics. For the calculation part, we have performed DC analysis to find out the efficiency of the circuit of this lab. The efficiency we obtained was 24.07%, which stated that is a class A amplifier, which we thought earlier class A has from 15% to 25%. Okay, I think we already achieved the objective of the assignment of power amplifier. That's all from us. Thank you very much.